this is part two of our research presentations. We had another presentation a couple of weeks ago, and I did give an overview of the Science Cluster program at that time, but just in case you had missed it, the Organic Science Cluster program is the national science initiative of organic agriculture in the country, and it is funded by Agriculture and Agri-Food Canada. The Science Cluster is part of a larger program where all of the major commodity groups, they all have their own science clusters, and so in the current, we just are wrapping up our last cluster, which is a 5-year program, and I think there was 15 different clusters in that program. The program, the organic cluster itself, was valued at about $10.5 million, and 75% of that funding was coming from the federal government and 25% from industry partners. We would not be able to leverage the government funding without the support of industry partners, and so it's really, really important that we recognize the industry partners and that worked on this project with the researchers. And this included not everyone from farmers up to commodity groups that contribute funding to the organic research. So if we want to have research like this continue, we need to have the industry support to leverage that government money. The Science Cluster program that we're presenting on today is the second Science Cluster that we've had. It ran from 2013 to 2018, and it actually just wrapped up here at the end of March. We have submitted a proposal for another Science Cluster program to Agriculture and Agri-Food Canada, and we're hoping to hear sometime within the next month whether or not that proposal has been accepted. So with that brief introduction, I'd like to get to the speakers themselves, and our first speaker is Lena Syrovy, and she's working is a research officer in the Agronomy and Weed Ecology program at the University of Saskatchewan. She completed her master's in that program and her bachelor's in global resource systems at UBC. She spent the last 15-year career as a dual citizen of both conventional and organic agriculture, working in a variety of horticultural and field crops, basic agronomy, pest, disease, and weed management. And so Elena's going to be presenting on seed, managing weeds and reducing yield loss in flax. So we'll have 15 minutes for each presenter, followed by 5 minutes of questions after each presenter, and I'll pass the presentation over to Lena.
Cool. Thanks for the introduction. So this is a project that our group at the University of Saskatchewan has been working on through the Organic Science Cluster, and we've been looking at different methods to manage weeds in organic flax. Probably a lot of you know that weeds can cause a lot of yield loss in flax. Flax is a fairly wimpy crop when it comes to competing with weeds. So this project had kind of two components. One was looking at seeding a cover crop between the flax rows as a weed suppression tool, and then the second component was looking at different mechanical weed control methods in flax. So first I'll talk about the cover crop part. So the concept here was to seed flax either alone or with a winter cereal growing between the crop rows. So we looked at winter wheat, fall rye, and winter barley as the winter cereals, and the thinking was that in year one, the winter cereals would stay vegetative and act as kind of a living mulch, if you will, and then the flax would be harvested for seed in year one. And then in year two, the winter wheat and fall rye would have overwintered. The winter barley would have winter killed, and we'd also have those flax sole crop plots. So we would have a mix of plots that had overwintered cereal and plots that had no winter cereal. and then we would grow those winter cereal crops for seed in year 2, and those plots that had nothing on them, we would plant spring cereals and harvest those. So year 1 was the flax year, and then year 2 was a cereal harvest. So looking at the results, we did see that those cover crops did help a lot with.
Could I just interrupt for one moment? Could you remind us when you're advancing your slides?
Oh, sure. Yeah. Yeah. So I'm on the slide that says weed suppression now. There's a graph there. Yeah. Yeah. I'm not used to doing this format. Sorry about that. Yeah. So we did find actually that having those winter cereals did help with weed suppression. With the fall rye and winter barley, we got about a 70% reduction in weed biomass compared with growing flax alone. I'm advancing the slide here. But what we also saw was that having that companion cereal was also really hard on the flax. It was really competitive with the flax. So just having a winter cereal growing with the flax reduced the flax yield by pretty close to 50% compared with growing flax alone. So it was quite a yield loss. The next slide, looking at cereal yields, we saw that the winter cereal and the spring cereal yields were pretty comparable to each other. We did actually see that some of those winter cereals winter killed, and I think the reason for that was that some of them actually decided to go reproductive before the winter. So we lost a little bit of yield there, but in general, the winter cereals yielded okay. They yielded about the same as the spring-seeded cereals. So from here, we started thinking about how we could maybe try to reduce the yield loss in flax to see if we could still try to adapt the system. So what we were thinking was that maybe we could reduce the seeding rate of that cereal and maybe get a better flax yield that way while still getting the yield suppression. So on the next slide, you can see that we tried that, and we really didn't see great results there. So we have on the right the full cereal seeding rate, and then in the middle we actually tried a half cereal seeding rate, and we still saw about the same level of flax yield loss just by having that cover crop there. So from there, I'm going to the next slide. We decided that this system was really not giving the kind of flax yield that we thought would warrant using this as a weed control method. So at that point, we decided to kind of move on from this part of the project. So we moved into the second part of the project, which was actually going on. It had started at the same time. That's the mechanical weed control part. So I'm on the next slide now. And we'd actually seen really good results in those first couple of years with the mechanical weed control component. So when we reduced or got rid of the cover crop component, we decided to enhance the mechanical weed control part of the project. So what this project is looking at on the next slide is a couple of implements. The first is the rotary hoe. So this is an early mechanical weed control tool that's used either before crop emergence or in flax. We typically wait until the flax is anchored, but the ideal timing is really based on the weed stage, and this is done when the weeds are just cracking the soil surface, so they're at the white thread stage, and the rotary hoe works by burying and uprooting those small seeded and shallow seeded weeds. So the benefit of this is that it covers the entire area, so it thins the weeds both in and between the crop rows. And then on the next slide, the other mechanical weed control tool we were looking at was the inter-row cultivator. So this is a tool that can be used a bit later on larger weeds. The disadvantage, though, is that it only controls the weeds in between the crop rows and not in the crop rows. And you can see our version, a person walks behind and steers it manually just to avoid hitting the crop rows. But I'm changing the slide now. There are also commercial, much nicer versions of the inter-row cultivator that are guided by cameras that sense and avoid the crop rows, and these are available on different row spacings to accommodate different seeders. So I'm changing the slide now. So to summarize the mechanical weed control tools, we have the rotary hoe. That's an early tool when the weeds are just emerging. And then we have the inter-row cultivator that's used later on older weeds. And then on the next slide is the part that we have enhanced when we kind of beefed up this experiment. What we'd seen from previous research impulses was that increasing the crop seeding rate really helps in suppressing weeds. So this is some work that we've done in lentil. The red circle is the conventional lentil seeding rate. And you can see just by increasing the seeding rate, you can get quite a lot more weed suppression. And that works by allowing the crop to divert more resources from the weeds. So when we moved into the next phase of this project, we included the factor of higher seeding rates to see if this could give us extra weed suppression. So on to the next slide. To summarize our system we were testing here for an integrated weed management system for organic flax, we had increased crop seeding rates. So we tested 4 seeding rates, and then at each of those seeding rates, we tested the rotary hoe and inter-row cultivation, either alone or together, as well as no mechanical weed control. So moving into the results on the next slide, we'll look at the graph on the left first. So that's the flax yield. And the first thing to notice was that increasing the crop seeding rate really increased the flax yield quite a lot. So by going from our lowest crop seeding rate of targeting around 250 plants per square meter up to our highest, which was targeting about 2,000 plants per square meter, we got more than a doubling of flax yield. And the red circle indicates where a conventional farmer would typically seed flax. So you can see when there are weeds there, we saw that there was really an advantage to going to higher seeding rates in flax. The other thing to notice was that the inter-row cultivator and the inter-row cultivation combined with rotary hoe gave an additional yield increase above seeding rate. We saw about a 22% yield increase by using either the inter-row cultivator or the rotary hoe plus inter-row. And now we'll look at the graph on the right of weed biomass. And we saw in some ways it was a pretty similar story. So increasing the crop seeding rate really reduced the weed biomass. So by going from the lowest to the highest seeding rate, we got about a 55% reduction in weed biomass. And again, that red circle is a conventional grower's target plant population. So again, quite a lot more weed suppression to be gained by going to a higher seeding rate. The other thing that we saw was that the rotary hoe plus inter-row cultivation treatment was the most weed suppressive treatment. We got about a 33% reduction in weed biomass by going to that combined treatment. The other thing that's interesting to note here is the rotary hoe alone. So you can see that's the gold dashed line. And in terms of weed biomass, it was actually pretty weed suppressive on its own, but you can see from the graph on the left that that didn't translate into a yield increase. So I'm advancing the slide now. And the reason for that was that the rotary hoe itself is pretty hard on the crop. So how we did these treatments was if we had the rotary hoe only, then if there was a second flush of weeds, we would use the rotary hoe a second time, or maybe even a third. We tried to avoid it. But when we had the combined tools, if we had a rotary hoe and an inter-row cultivator, then we could replace that second rotary hoe application with an inter-row cultivator pass instead. So when we did that, we saw quite a lot less crop thinning. So the crop was more tolerant when we used the rotary hoe less often. The other factor that was important here was the seeding rate. We got a lot more crop thinning with the low seeding rate, and as we increased the seeding rate, the crop tolerance to the rotary hoe increased. So the recommendations that we've gleaned from this is that the rotary hoe should only be used once in flax to avoid excessive crop thinning, and it should only be used with a high crop seeding rate. I'm advancing the slide now to some pictures of plots from 2017. So we did do this enhanced version of the experiment over 4 site years in 2016 and 2017. These pictures are all from 2017. This first slide is our Goodale site southeast of Saskatoon. So on the left are the lowest seeding rate plots. So you can see it's really hard to see the flax rows there. They're really weedy. This site was really weedy in general. And by going to the high seeding rate on the right, it helps a lot by itself. So even the control plots, you can see the crop rows, and they look generally a lot better. The rotary hoe, maybe some tolerance issues, maybe a bit more crop thinning that allowed the weeds to take over there. But in general, going to that higher seeding rate, the plots look a lot better. And then using the inter-row cultivator or the rotary hoe plus inter-row with that high crop seeding rate, the plots looked really pretty clean for how weedy the site was. And then on the next slide, we saw a pretty similar situation at our other site in 2017. This is the Kernan site on the University of Saskatchewan research land. So on the left is the low seeding rate. On the right is the high seeding rate. So again, the crop rows look a lot more visible with that high seeding rate. Looks like the tolerance to the rotary hoe is better. And again, that inter-row cultivation treatment or the rotary hoe plus inter-row cultivation treatment looks the cleanest. So yeah, our outcome, I guess, of this project was that using an increased seeding rate with either the inter-row cultivator or combining the rotary hoe and inter-row cultivator at that high seeding rate were our most effective methods to control weeds in flax. So on the next slide is just a picture of our group, and Steve Shirtliff is the agronomist at the University of Saskatchewan, the professor of agronomy, and that's our group. And then the next slide is thanking all the students and the research staff who were involved with the project, as well as the funders through the Organic Science Cluster. So that's it for my slides.
Great. Thank you very much. Talking about being right on time, that was fantastic. Thank you.
Perfect.
And we'll just reinforce the acknowledgement on the industry partners. So in this project, we had the Western Grains Research Foundation providing the industry support this research project. So with that, we have a few minutes for questions, and so I'll open the lines up for questions.
Okay.
I guess I have a question.
Sorry,
sure.
Go ahead.
I said I guess I do have a question. You've shown that the increased seeding rate is beneficial, but there must be a point where it becomes detrimental. Did you do any findings on that?
Well, I think what you're referring is to the economics. Is that kind of what you're getting at? I guess, like, in terms of yields, the yield was still going up at the highest seeding rate that we tested, and I suspect the rate of increase will slow down, but the yield won't go down, but it will become less economical to add more seed as we do that. But I haven't finished the economic analysis yet. But I suspect, just from kind of our preliminary analysis, that it'll probably be most economical to seed around 1,500 to 1,700 target plants per meter square, but I still have to confirm that. Yeah.
Great.
Yeah.
Another question. If not, then I'll ask one. I'm intrigued by, I think this is really interesting work, and I'm looking at some of your slides and the soil conditions that you're working under. And it looks like you're probably on a little bit heavier textured soils without any stones on them. So would these practices that you're talking about be applicable to all soil types, or are they more specific to the conditions that you worked under, and what were they, I guess?
Okay, yeah. So we actually do have quite a bit heavier soil at the Kernan site. There's quite a lot of clay content. It can be fairly rocky in some spots, and we haven't seen an issue with that with the rotary hoe. I know a lot of growers have asked about that, but I think maybe it has something to do with the type of rotary hoe. Ours is just it doesn't have any hydraulic component or anything. It's just totally the weight of the implement that is having the effect on the weeds, I guess. It's so it's not very deep into the soil, so we haven't seen an issue with rocks there. Our other site, at the Goodale site, actually it is quite a lighter, sandier soil, and that's the site where we saw quite a few more weeds. But in general, we've seen pretty much the same patterns at the different sites. The implements still work at both sites, although I guess the main thing we could see was the weed populations are quite different. I don't know if that answers your question, or if you...
Oh, I think that's very helpful. So, are there any other questions before we move on to our next presenter?
I have one. I'm just curious about the impact of how much moisture there is in the soil at the time of running through with either of your pieces of equipment. And there was some difference between 16 and 17, whether you noticed that to be a impact as far as your effectiveness.
Right. I would say in general, if there's more moisture, the efficacy is a little lower of these mechanical weed control tools. It's also a bit more challenging to get into the fields, right? So one thing that we saw in 2017 was that with the inter-row cultivator at our Goodale site especially, it got quite a bit more rain, and some of the weeds re-rooted after the rain, so we had to come back and do it again. I guess that's the main thing that we noticed. The other thing, I guess, when it's hotter and drier, the weeds are more likely to die and desiccate, but with a crop like flax, something like the rotary hoe can also be a bit harder on the flax when it's hot and dry, because it's also kind of a shallower seeded, small seeded plant. So it's I guess going somewhere in the middle is ideal, but I guess the conditions are rarely ideal.